This is Pete Meyer. This is a re-recording of a portion of the SBGrid webinar lineup. This was presented earlier today. Previous SBGrid webinars and upcoming webinars are shown on the screen, and you can see the link there. Today I'm going to be talking about remote work and structural biology computing. This is not going to be presenting a magic bullet, but this is going to be presenting a couple of different tools that you can use to try to be more effective when working remotely. So the typical structural biology computing lab setup looks something like this cartoon here, where you have graphics workstations. Maybe they have stereo on them. Maybe you have Mac workstations. These are quite frequently connected to file servers, possibly compute nodes, GPU nodes, especially now with the rise of GPU computing for cryo-EM. You may have authentication servers so that you use the same username and password to log into all the different workstations. You may have various other services. Very frequently, there are Wi-Fi networks you can use to connect to some of these things from your laptop. You have sysadmins to make all the various pieces running smoothly, and you have researchers using the various systems and doing research. These days, there are a larger number of labs where the setup looks something more like this, where all of those lab systems, they still exist, they're there, but you can't go into your home institution or your lab and physically work on them anymore. So maybe you've got your laptop at home. Maybe you've taken one of the workstations at home with you because your institution's trying to facilitate working remotely. Just as a side note, if you do that, be aware that you should check with your system administrators because it may depend on some of the file servers or other services that are not accessible from your living room. So one other thing to keep in mind about this kind of setup is that your system administrators are also offsite. And so any problems that might be easier to fix may take longer to fix now in the current setup. But the point being, all of these resources are still there. You just have to access them over the network or have to come up with new ways of working. So it can be helpful to step back at this point and think about what do you actually need and how do these things generalize to adapt to a new setup? Because if you look at it generally, scientific computing in general and structural biology computing, what you're doing is you're reading some data, you're doing some math on it, and you're writing out the results. Then you're looking at the results. Maybe this is output files, maybe this is log files. And you're deciding, what does this tell me about what should be done next for data analysis? What does this tell us about the biology of the system? Should we go back to the bench? How do we phrase this in paper? And so that boils down to, on a computational level, you have data, which is your inputs. You have software, which is responsible for doing your math. You also need compute, which is for running the software. So that means doing the math that you want to do in a reasonable amount of time with enough cores, enough memory, enough GPU coprocessors. You need enough storage to store your original data, whatever working data you've got, and your outputs. And you need an interface where you can talk to these things and look at the results and decide what to do next and kick off new jobs and analyze the results, looking at them visually. So in the context of remote work, there's another component that we add to that, and that's the network, which, depending on how you do it, it may be relatively important, it may be critically important. So you can think of the approaches for remote working as being divided up into two extremes and then hybrids in the middle, which are probably going to be more typical of how folks work. And how you go back and forth between these two approaches is going to depend a lot on the particular type of computing that you're doing. So at one extreme, you can do everything all locally. If you're in a case where you're able to do all of your structural biology computation on your laptop and you've brought your laptop home with you and you have your data, then working from home is basically the same as working anywhere else. The other extreme is you have all your remote resources available. You just use your whatever home systems you have as effectively kind of a dumb terminal, and you just connect to your remote site and do everything there. Your network is incredibly important at that, and it's going to be you need good bandwidth, you need good latency. And then for the hybrid approaches, you can mix things and trade off depending on what you're trying to do. And we'll talk about these a little bit more in later slides. So just to mention some terminology that gets thrown around a lot when talking about working remotely. So SSH is a tool that people may be familiar with already. So it's a secure cell, and basically you use it for remote terminal access to connect from one system to another system. This may be something that people use internally at labs where you sit in front of a graphics machine and you make an SSH connection to a compute node or a graphics node and just use it there. So people may be familiar with that already. A VPN, or virtual private network, is a way to provide secure access to network resources over a wider internet. So one example of this would be you might be at home and you'd like to access your lab file servers. If you connect to a VPN, you should be able to do that, and depending on how they're configured. And that makes essentially your network access, that essentially makes your remote network connection act like a local network connection. You do still have performance concerns about that, where it's not going to be as fast, but you'll have a connection. So NFS stands for Network File System. It is a way to do local network file access, and it's usually not accessible over VPN for security reasons. So SMB, Samba, and CIFS are three names or acronyms for what there may be technical differences between them, but you can consider them as the same thing. And that's another way to do network file system access over a local network. That is more frequently something that is made available over a VPN. SSHFS is a way to wrap SSH and make it act like a file system. And this can work over a remote network connection as well. You may not have the best speeds and the highest performance, but it will work with relatively minimal configuration. So a bastion host or a jump host or a login node is a phrase that's used relatively frequently in remote access because you don't want to have all of the systems in the lab accessible to everybody on the internet, because if you do that, everybody on the internet includes people who are going to try to get into the systems and do possibly nefarious things. So you use a single system that has higher security, that you don't run jobs. You connect to this system over SSH, and then from there, you connect to the workstations or the compute nodes where you're actually going to be running your jobs. If you are using a VPN connection, then most likely you will not be going through a bastion host. But if you are not connected to a VPN, you'll probably need to go through one to get access to compute resources. So X or X Windows, X11, Xorg basically refers to a way to do Unix GUIs that are relatively basic, and by basic I mean not too intensive graphically. So these are things like the CCP4I interface, the Phoenix GUI, NMR pipe, something where you have windows and interactions, but it's not too graphics intensive. OpenGL, or sometimes people will refer to it as just GL, these are much more graphics intensive GUIs. So these are things where you're looking at large structures, you've got electron density, you're doing partially transparent surfaces and trying to render figures. So these are things like Qt or PyMol or Chimera or Maestro, where it's still a GUI, but it puts a heavier load on the system. And these can be more problematic for running them over a remote network connection. VNC is one remote graphics protocol. There are several different clients and servers that either do this basic protocol or do this protocol with additional add-ons for more security or better performance. So the first approach is the pure local approach. And I already alluded to this, if your job is let me run compute that I can do on my laptop and my data fits on my laptop, then it's very simple to set up. This kind of approach can also apply if you have a home desktop or a lab workstation you brought home. Relatively speaking, you probably have less compute resources and less storage resources available than you do in lab. But if your job fits into those resources, that works perfectly well. You need to have software installed locally. This may be something that's already installed. If not, then the SBGrid has a client installer that lots of people have been using to get set up to run structural biology computation on home systems or other systems. So one of the good things, or two of the good things about this approach are that the graphics latency is very low. So this is good because you're not trying to run graphics over a network, but it assumes that you have a good graphics setup at home, which if you have a gaming computer, that's great. You can probably run Qt or Chimera with reasonable performance. If you're trying to run on your integrated graphics card on, say, a MacBook Air, you may have low lab graphics latency, but their performance may not be great regardless. The other advantage to this is that you don't have to worry so much about your ISP connection. You want to keep in mind, though, that if you're working from a laptop or working from home for the first time, you do want to think about ergonomics a little bit. Because, if you're traveling, you can work on a laptop and it'll get by. But if you're trying to do it for weeks or longer, you're probably going to be more comfortable with an external keyboard and mouse and most likely a second monitor, possibly a larger monitor. Particularly if you're doing something where you're doing 3D graphics in Qt or Chimera or Maestro or anything where you're dealing with a molecular structure or electron density, a 3-button mouse really helps. And if you just have a trackpad on a laptop, you may find yourself getting more frustrated. The other point to mention about this is you should check your backups before you have a problem, because this is something that about, I would say, half the time when I talk to people about, okay, so you're working remotely, how are your backups? And you get the expression of, oh, that's a good idea. Why didn't I think of that sooner? So think of it before you need it and check your backups to make sure that you have something. This doesn't have to be anything involved. If your backup is, I have Dropbox and I keep all my files there, as long as your Dropbox connection is working, you're fine. Your institution may also have something available for backups. So that's definitely something worth looking into. The other extreme approach is to do a pure remote. So in this case, what you need at home is a very minimal setup with a browser, usually SSH, possibly a VPN client, possibly a VNC client. And you don't necessarily need to have any structural biology software installed locally. You also don't need, you don't need very much compute power at home to drive this approach. The trade-off to that is that your home ISP and your network connection becomes extremely critical. And if that gets interrupted, then that will interrupt whatever you are in the middle of trying to do. There's less local configuration. The trade-off is that you need remote resources to exist. If you're going to be using existing lab resources or existing institutional resources, those have to be there, and they have to be something that's set up for remote access. If that's lots of places have already set that up. If so, that's great. But if you're in a situation where somebody would need to go on site to make them available remotely, that may be problematic. Another alternative is to use cloud resources for your remote computing. And I'm going to be talking about AWS and walking through an example later on, but that's just an example of this is a cloud provider that will give you VMs. If you wanted to run this on Microsoft Azure or Google's Compute Cloud, you should do that as well. The point being just you want compute resources somewhere, and the cloud is a way to provide them. Graphics can be more problematic with this approach, as I've mentioned, and that will depend on what type of graphics you're doing. So the hybrid approach has the best and worst of both of these worlds. So you need more setup on your local side, you need remote resources to exist, and you're relatively sensitive to how the network is set up. But you can structure your workflow in such a way that momentary interruptions of your network connection, or the network bandwidth being limited because everybody's running video conferences or streaming videos at home, you can structure your workflow so it's less sensitive to those. And how you set this up and which parts you run where is very workflow dependent. And so one example that I'm going to run through is basically you run your compute jobs locally, copy or synchronize your output files, and look at the results locally. So I'm going to attempt a live demo, and this will be the very low-tech way to do remote computing, which works and there's nothing wrong with it, but it is not necessarily a workflow that everybody makes use of. So here I have a structure and I would like to refine that structure. I have a script where I'm running my refinement. Again, this is an example. Don't actually refine your structure this way. Don't use these parameters to refine your structure. So I'm going to copy my data, my script, and my model to a remote system. In this case, Crystal 2 is a SSH alias for our Bastion host. So now I'm going to connect to our Bastion host. I can't run any jobs here, but I am sharing a file system with the node that I'm going to be running the job on. So now I'm on our Bastion host. I'm going to connect to my workstation. And this workstation is about a half-hour walk from me in Longwood in a building that is currently off limits to me. So here are my files, and actually you can see the files from where I ran this previously. But so now here we are. I'm going to source the SBGrid programs to set up the environment. And now I'm going to run my refinement. Actually, one step that I have skipped over. So I'm going to start a tmux session. You should ignore these error messages here. They come because I have done some involved things with too much configuration. But the point of starting a tmux session is that if my network connection drops off right now, then my jobs will not be interrupted. That does not matter for this toy job that will run in a minute or two. But if you are kicking off a job that is going to run for 6 hours or 2 days, you don't want it to have to be interrupted because the network glitched. But regardless, I'm going to start running my refinement. And this should go reasonably quickly. Yep, and we are already done, and now we're writing our outputs. All right, so I could take a look at our log files here, and I'm going to disconnect from our tmux session. So refinement ran. Look, I have R work and R free, and they are numbers. Refinement exists. So if I wanted to look at the model with Coot through this, that obviously is not going to work over a straight SSH connection. So what I'm going to do is I'm going to log out, and I'm going to copy those files back here. And again, here, Europa is the name of the host name of the laptop that I'm running this demo from. So I have my files here. I'm going to source the environment again. And then I'm going to open up my outputs in Coop. And again, the fact that I'm running the graphics on a Mac and I ran the refinement on Linux, that doesn't make a difference in this case, but Coot is here. It works reasonably, it works well enough on this system. The main limitation here is the trackpad, which if I was doing this for non-demo purposes, I'd be using a 3-button mouse. So that works, but it's not a workflow that a lot of people are comfortable with. And it means that you can't take advantage of the improvements that developers have made with GUIs for interpreting the results, showing you possible problem areas. So we'd like to do it a better way. And jumping very briefly back to our slides. So that's going to be, we're going to do Phoenix refinement take 2, and we're going to do this with the more common approach of using the Phoenix GUI. So I'm going to connect, and I'm going to connect with a slightly more involved syntax this time. So SSH is the same, -C is going to compress it. I'm going to use, I'll explain these after I type in. And I have to type them all correctly or it won't work. So what this syntax is doing is I'm forwarding port 8042 on my local system to 8042 on a remote system. And this is our bastion host, so I'm going to have to do this a second time. So copy and paste. Now I'm going to go back to our bastion host, or now I'm on our bastion host. I'm going to go to my Linux box. Now I'm forwarding 842 locally to 842 remotely. There's nothing there yet, but we're going to fix that. So I have here a script that I'm going to use to start up a Expert desktop session. If anybody's watching this recording that was watching live, we had some technical issues the first time around. Those should be sorted this time. So I don't have any Expert sessions running yet. I'm going to start one. It's going to be listening on 8042. And one thing about these numbers, so the particular numbers don't matter. They just have to be consistent. So I picked 8042 essentially off the top of my head. I could have picked 60, 20, 23, and it would have worked just as well as long as I was consistent throughout. So one thing to note about this command, so I'm starting a desktop. It's desktop number 42, which I picked essentially arbitrarily. This is starting a mate desktop because that's the Cent7 desktop I'm most familiar with. We're listening on a TCP socket, which you can ignore, and we're setting a password so that, again, this is not the most secure of passwords. This is for demo purposes. But the reason for doing this is because this is a shared workstation. So anybody who could connect to this workstation or connect to this port on this workstation would be able to access my desktop again, which sometimes that's what you want if you're saying, hey, can you take a look at my results and see what I've got there? But it's generally something you don't want because then somebody could pop on the network and have write access to files in your home directory. So we have an Expert session. It should now be running. Here we are. And so now I'm connecting to it in a browser, and I'm using Safari. I've used Firefox. Chrome should work as well. And actually, before I do that, one thing to mention here, I'm going to start another TMUX session. The reason for this is because sometimes SSH connections will time out after periods of inactivity. And if that happens, my SSH tunnel will drop and my network connection will freeze. So. And I'm pretty sure that that's, yep. And now we've connected, and this is the same desktop environment I would have if I was sitting in front of the system. Obviously, it's a little bit smaller. I have a bigger monitor in lab, but that is how things are. So we're going to go into our demo directory again. Activate the SBGrid environment. And we're going to start up the Phoenix GUI. And again, all of this, as you can probably see, this is where it killed previously. So we are going to override the lock. And where is my demo project? My demo project is not there, so I'm going to start it up again. All right, now I'm going to go into my demo project, and I'm going to run Phoenix Refine. This is not going to be any particular, the point of this is not to focus on Phoenix or how to do refinement. It's to show you that you can do all of this remotely over the network. So we're going to run. Again, rerunning the same job. CUDA is going to start up and follow along in a very similar way as it would if I was sitting in front of the desktop. So now we have better graphics. We have graphical plots that people have thought about the UI for how do we present this information, how do we report errors, how do we show things that are a lot clearer than let me look through the text file and hunting around what I'm looking for. And now we're up and running. So this is when I'm not going to wait for this refinement job necessarily to finish, but it does finish. I've run through it several times, and you get surprisingly good performance out of connecting to the remote system this way. So I'm going to leave this run, and yep, you can see we're live updating. So that's our Phoenix demo take 2. Not everybody is a crystallographer, and refinement in the Phoenix GUI is good, but if you're doing cryo-EM, okay. I want to do Reliant, and I want to do GPU computing. So I'm going to leave this running. I'm going to switch. So here I'm in my remote desktop session. I'm going to switch to another virtual desktop because I'm one of the people that likes to use virtual desktops to keep things organized. And we're going to see what we can do with Reliant. So this is a previously set up example for the Reliant tutorial that you can find online. It's very well documented and put together. One thing you may note here is I'm setting up Reliant with a version override to use the CUDA 9 acceleration. And I will start up a second terminal window to, I'm going to close that. Okay. So here we do have a GPU in the system, and it's CUDA capable. It's a RTX 2080. I'm going to start up Reliant here. As you can see, this is a previously run job, so I'm going to try to run CTF correction. Just rerun this again, and let's see, what can we do here? So I want to set it up. So we are using, we are using GPU 0. Let's see, can I rerun this job just by default? Away we go. And no, because it's too smart and it knows that we've already done this. So, all right, this looks like my Reliant live demo is going to not perform tremendously. But one thing that I can show you here, CTF correction, my mistake. We are going to run our CTF correction successfully, I hope. It is running. We are now running Reliant on a remote GPU, and with the GUI as if it was hooked into our desktop. So I apologize for my inexperience with the Reliant GUI and the cursive live demos for the delays, but functionally this works. And when this job is finished, we should be able to say, show me the outputs. Obviously, I should have done that beforehand. So let's see if and we have just finished. So here we are. We have done CTF correction on a GPU on a system that we've only accessed over the network. So those are two examples of ways that you can use Expra. And again, that's just one tool that you can use. That's the one that I'm not going to talk about the others in as much detail. But again, that's using an existing workstation that's already set up and configured. So what we're going to walk through next is what's involved in setting this up. And I'm going to use a CentOS 7 machine in running on AWS to show that this is not actually tremendously involved to get up and running. So, and again, the details of these steps will differ depending on which cloud provider you're using. But if you are on a different cloud provider, it will work very similarly. You're going to be picking what you're going to be configuring the virtual machine, launching it, connecting to it, installing software, and using it. And those should stay the same regardless. But for AWS, there are what feels like an infinite number of AWS services. EC2 is the one that you use to launch virtual machines. So we're going to go into EC2. We're going to choose an AMI to essentially select the operating system and the software installed for the virtual machine we're going to start up. I'm going to go with one of the official CentOS 7 ones because that's what we use in our lab. CentOS is well supported by SBGrid, so that seemed like the way to start. The next step is to choose your instance type. So this essentially corresponds to which hardware do you want your virtual machine to have. And one thing that you want to keep in mind here is that many of these AMIs do not have a tremendous amount of storage by default. So for example, if you are starting a virtual machine that has 8 gigabytes of storage and the operating system, including a desktop environment, is going to use 6 gigabytes and you would like to install, let's say, Phoenix, Rosetta, CCP4, Relion, Chimera, you are going to want more storage than that, and it won't all fit in 8 gigs. So you may want to add some secondary storage. But once you've selected your hardware and configured it, there's a couple of steps for tuning it, and then you actually launch. Before you launch it, or in the process of launching, you are prompted to use an existing key pair or create a new key pair. What this is another way to connect to a system over SSH in a way that's more secure than using a password. So one of I'm not going to talk about private key or asymmetric cryptography in any amount of detail, but the short version is that you have a public key that you can pass around wherever and is used to validate you, and a private key that you should keep to yourself, and that is essentially cryptographic certificate that you're the person on the other end. So this is something where people on the internet are not going to be able to go through the dictionary and try to guess what's in your private key, or at least as far as I've heard, nobody's doing that yet. Whereas if you're using password login, that is an issue. But regardless, the short version, if you can ignore all that, you want to download the private key file and you want to keep it someplace secure, and you don't want to lose track of it. Once the instance is up and running, you have the option to connect to it over SSH. We're going to do that in a very modified way. But these examples, these connections are basically SSH-I with my private key, the username, which will vary depending on the AMI, and the public host name, which will vary depending on every time you start up a new VM. So here, this is a copy and paste of what I entered in the terminal, because screenshots of terminal windows are not the most effective way to convey this. And also, this takes a little bit of time to run, not for person side, but just for running the software installs. And again, these slides are available online through the link. So if you wanted to copy and paste from the slides versus trying to read from the video. But the first block of text there is us connecting to the VM. And we've added a little bit to what the instructions told us. We're still doing the key pair, the -i demo.pem. And then we're adding what would look very familiar from when I was establishing an SSH tunnel to my lab workstation. We're doing -c for compression, and we're doing -l for port forwarding. And in this case, we're using 8045. And again, those are arbitrary as long as we're consistent within what we're connecting. So the first block here, sudo su, I'm connecting as the CentOS user, becoming root, installing tmux, leaving that tmux set, or exiting the root session and starting a tmux session. And the reason for that is I don't want to have my software installs or my configuration fall over because the network connection drops. That sometimes happens. When I was putting together these slides, I had about 2 or 3 times that my home network connection dropped out. So that's something where it's not a problem as long as you take into account when you're setting things up. So and these are basically these yum commands. I'm installing things for the operating system. So these are just some initial dependencies. Mate desktop, again, because that's the desktop environment I'm familiar with. This last yum install is me installing basically things that I copied and pasted from the SBGrid wiki page on how do I set up my workstation. These are the things that SBGrid software is going to assume that you have installed, so we're going to install them. The next block, which is still being run as root, is where I'm installing Xpro. And this is just import the key, import the repository, install it. Then exit the root session. Now the system is configured, but I don't have any software configured. So following along many of the presentations that we have been given about how to use the client installer. So I'm not going to go into detail here, but you should definitely check those out if you're curious. But I'm going to download the SBGrid installer, unpack it, go into that directory, activate it using my site key, or site username and key, and then I'm going to install Phoenix and Coot. I could install more software, but for this demo, I'm just going to install those 2. And then this last command here, I'm going to start up at a desktop. And again, this is the only difference here is that this 45 and this 45 are different from what I was doing on my workstation. So that, I guess, kind of illustrates that this is something that can be transferable. So I'm treating the virtual machine in Amazon's data center in Virginia the same as I'm treating my lab workstation, down the road. Once that's done, open up a browser window, same as we did previously. I've already copied the files here, but the copying them over SSH works out the same way. Phoenix GUI still runs, and as you can see, now we're doing this all through a remote connection, and it works pretty much. You've got a Linux VM that you're connecting to. It works the same way as a Linux machine that you're connecting to that's a physical machine, except this particular one does not have a GPU. So if you wanted to try to do CUDA computations on it with Relion or CTF find or anything else, you would have to pick a different you'd have to pick a different instance type to run your AMI on. So when you're done with your VM in the cloud, you should copy your data files off, and then you should shut down your VM when you're done with it. And there's 2 reasons for doing that. The first reason being that you're going to get charged for the runtime of that machine. So if you're not doing anything on it and you leave it on for a couple of days, you're going to keep racking up charges for that. So you definitely want to stop it once you're done. And the second reason is that while your machine's running and you're not using it, you're using resources. And if everybody is using resources they don't need, then that's going to make it harder to get resources when you do need them. So there's also a difference, at least in AWS, between stopped and terminated. Stopped means, I've shut it down, but I might turn it on later because I realized I forgot to copy some files off. Terminated means it's gone. If I forgot to copy files off, it's too late. I have to rerun the job. So that brings us to the end of the AWS walkthrough. And just a few links to resources that we've talked about here in the past. So a link for the SBGrid client installer, that's useful both for installing on home systems and installing on cloud systems. Expra, which is the tool that I've demonstrated for doing remote desktops, but again, it's one tool. It's open source, is available there. Real VNC and FastX are two alternative ways of doing remote graphical desktop environments. These are both commercial products. They generally have a prettier GUI than doing SSH tunnels does. So that may be something to consider. Another thing to keep in mind is that your institution or your group may already have licenses set up for Real VNC or FastX. So Real VNC is something that we use at SBGrid internally. It works very well, and actually I will show you a very brief demo of how do I connect to a machine with Real VNC. And if you'll notice here, I'm launching an application and I'm clicking some icons on a screen. I don't have to do any SSH tunnels. But once I've connected, this is another remote desktop. So that's something to keep in mind for when you're picking what tools work best for your environment. There may be trade-offs between the user experience, the configuration, and the cost. So AWS is Amazon's cloud provider, which, as I've mentioned, you can use anybody that's going to provide you a virtual machines over the internet. The similar approach will work. So AWS Workspaces is something that I have heard good things about for Amazon's tool for graphical desktops. I haven't personally used it, but I've heard good things about it. VirtualBox I'm mentioning here, it's not strictly speaking remote work, but everything that I've talked about assumes, oh, you have a laptop at home, well, your laptop must be running Linux or Mac OS, right? Oddly enough, there are lots of people in the world who use Windows, but SBGrid software doesn't support Windows. One possible workaround, depending on what you want to do, is to install a virtual machine to install a virtual machine running Linux. VirtualBox is a tool that you can use that. That's something that, depending on your workload, may be a solution, may be more trouble than it's worth. And the last resource that I can't put a link into because it really is audience specific is your institution or your department or your group probably has resources for how do I work remotely. And they are probably rapidly evolving and improving those resources as time goes on. So if you should check to see what's available, and you should work with those people to see if you can find ways to make things work better. And that's one, yeah. So transitioning into some unsorted things that I may have mentioned in the past or didn't fit into any particular place, you definitely want to allow for network interruptions. So if you're running jobs from a command line, run them with a scheduler like Slurm, LSF, PBS, or run them in a TMUX session or a screen session where if it gets interrupted, your jobs will keep on running. That also means if you're doing just simple X11 forwarding with SSH-Y or SSH-X, it's going to drop at some point. And by Murphy's Law, it's going to drop when you're in the middle of something. So you'd be better off using something that's going to preserve state, whether that's a VNC server, an Expert server, no machine, but something where there's some state preservation. One other thing to mention, particularly for people if you're not used to using VPNs, is that you only want to be active on one VPN at a time. So you could be in a case where your institution has said, we have a VPN, and your lab has said, we have a VPN, and your collaborator has said, we also have a VPN. So you have 3 VPNs installed on your system. You don't want to have them all active, and you don't want to be connected to all 3 of them at the same time, because that will probably lead to some unpredictable behavior that will confuse you and will confuse anybody you're trying to get to help you with it, and you don't need to. So just be connected. If you're on a VPN, be on one at a time. So for SSH, this is just, we've talked about SSH tunnels a little bit, and this is just talking about the syntax here. So I'm not going to go into all of the amazing things that you can do with SSH. There's a lot it can do that I never use it for and would have to look up in the manual, but this is a shortcut. You don't need to look in the manual to do it this way. -C for compression. I find I get better performance with this, particularly if I'm tunneling a graphics desktop. And that becomes more of a factor, again, if you're on a network where everybody's running video conferences and streaming videos. So host activity timeouts are something that I've mentioned, where if there's no traffic going over an SSH connection for a period of time, the system may say, all right, this is idle, I can drop it. So you don't want that to happen if you're tunneling, and you may not want that to happen if you are in the middle of doing something. So two less technical tips to end up with is it takes time to get comfortable with working remotely and figuring out what your workflow should be and how to adjust it. Because a lot of it really depends on how are you doing your data processing and what are you doing. And this is an area where lots of people are rapidly trying to figure out what is the best way to do this. If you have questions, then feel free to reach out to us. And taking time to get comfortable, that's with how your workflow works, that's your ergonomics, that's, how does it work? The last thing is that you don't want to spend all your time in front of the computer. So it is very easy if you're a researcher and you're in the zone and you're sitting in front of your computer and, you got up at 9, you didn't have to commute with your cup of coffee and you're processing your data, and all of a sudden it's 8 o'clock and you haven't had dinner. You don't want to spend all of your time in front of the computer. You should get up and do some other stuff on occasion. So with that, I'd like to thank everybody else in SBGrid who's been all involved in a lot of things that I'm sure you folks are aware of. And with that, I will conclude the recording.